Every electric vehicle on the road today carries a hidden vulnerability engineered into the very cells that power it. A vulnerability that has claimed lives, destroyed fleets, and cost billions. Until now. Introducing the hybrid power pack, a patented dual storage energy architecture from Rohera Emerging Energies Private Limited, designed to structurally eliminate thermal runaway, extend battery life by up to 192%, and deliver instantaneous power response. With the science and the patents to prove it. 6 granted patents: India, the United States, Japan, Australia, Israel, Eurasia. This is not an incremental improvement. This is a fundamental reimagining of how energy is stored and how lives are protected.
To understand why the hybrid power pack matters, you must first understand what it replaces. Lithium-ion cells store energy chemically. Under a sudden surge of current, acceleration, a collision, overcharge, or extreme heat, that chemistry becomes catastrophic. A single compromised cell climbs past 200 degrees Celsius. Oxygen releases from the positive electrode. Adjacent cells ignite. The chain reaction is unstoppable. Fires that burn at over 1,000 degrees Celsius. Fires that reignite hours after they appear extinguished. Fires that no conventional coolant can suppress. This is not a manufacturing defect. This is not a quality failure. This is a fundamental limitation of chemical energy storage, present in every conventional battery pack in production today, and it has been accepted as inevitable until the hybrid power pack. The hybrid power pack solves this, not with a patch, but at the architectural level. At its foundation, a bank of lithium iron phosphate cells for deep, sustained energy storage, paired with a supercapacitor bank precisely calibrated at 3 to 5% of total capacity in EV applications. And governing every electron, a patented battery management system, coordinating charge and discharge with microsecond precision. Here is the science that changes everything. Every peak current event, emergency acceleration, cold start cranking, sudden load, is routed entirely through the supercapacitor bank. Supercapacitors store energy electrostatically. There is no chemical reaction. There is no heat chain. Thermal runaway is physically impossible. The lithium cells never experience the current spikes that erode electrodes and trigger failure. They operate exclusively within their optimal state of charge window, protected, stable, enduring. Battery degradation has 2 primary causes: destructive peak currents that fracture electrode structure, and heat, the I²R heat generated when high currents flow through internal resistance. The hybrid power pack eliminates both. By routing all peak demand through the supercapacitor bank, the lithium cells receive only a smooth, averaged current profile. I²R heat generation falls by 91%. Electrode wear slows to a fraction of conventional rates. And the results are not theoretical. In rigorous independent testing, CERT conducted boiling water bath cycling across 10,000 full charge-discharge cycles. DRDO verified high-temperature discharge performance at 70 degrees Celsius. Both confirmed with the patent data established. 6,648 cycles in the hybrid power pack, against just 652 in a conventional pack. 192% more battery life, from 3 years of service to over 9. Not a claim, a measured, certified result.
Regenerative braking is one of the most powerful efficiency tools in the electric vehicle, and one of the most wasted. When a vehicle decelerates, its motor becomes a generator. A short, high-current burst of energy surges back toward the pack. Conventional lithium cells cannot absorb it fast enough. That energy dissipates as heat. The electrode absorbs mechanical stress with every single stop. The hybrid power pack supercapacitor bank captures regenerative energy instantly, in under 20 milliseconds. No current limit, no thermal load. Every joule of braking energy stored and held, ready to propel the next acceleration demand. In verified testing, hybrid supercapacitor systems improve regenerative braking efficiency by 8 to 12% over conventional lithium-only packs. In a vehicle driven 40,000 kilometers per year, this translates to measurable range extension and a pack that outlasts anything before it. Efficiency recovered, energy preserved, nothing wasted.
For engineers, a critical question demands an answer. How much supercapacitor capacity is sufficient? The hybrid power pack answer, validated through patent testing and field data, is precise. 3 to 5% of total pack capacity in EV applications. This is not a compromise, it is an optimized engineering ratio. At this proportion, the supercapacitor bank handles 100% of peak current events. It absorbs every regenerative braking pulse, and it holds the lithium cells in their optimal operating window, adding no meaningful weight and no meaningful cost. Consider what conventional dry cells offer: no peak current buffering, no regenerative capture, rapid degradation under cyclic load, and no pathway to improvement. The hybrid power pack replaces that limitation with a system built on physics, a system that only becomes more valuable with every cycle. 3 to 5% supercapacitor, 100% thermal safety, 192% more life.
The hybrid power pack carries the full weight of international intellectual property law behind it. Indian Patent 301517, U.S. Patent 105-23019B2, Japanese Patent 66448883, Australian Patent 2015101232, Eurasian Patent 035682, Israeli Patent IL 256796.